Okay, this is the second lecture of the lighting lectures. As you know, it's divided into two parts. Last time we took the first part. And last time we talked about the main terms and basic terms in lighting, like lumens, efficacy, and all these. Today we're going to talk about more advanced concepts in lighting. Okay, there are still the basic concepts, but they are more related to design. So we're going to talk about this content. So we have first we're going to talk about the visual task and how to improve the performance of a visual task. Then we're going to talk about the characteristics of that visual task. And as we can see here, the three in here, these are part of the characteristics that are related to visual task lighting. Then we have equivalent spherical illumination. This is a used measurement for lighting. And then we're going to talk about in general how lighting is related to humans and what are their needs that we need to take into consideration our design later on. And here we're going to talk about at the end about a summary of rules of lighting design. So first, let's talk about the performance of a visual task. What do I mean by a visual task? A visual task is a task that needs lighting or visibility, let's say. So for example, in here, what you see is they are all reading. This is a visual task. Reading, this is the visual task in these characters. As you can see, a rule of thumb, or let's say in general, what we need for reading is good lighting, clear writing. Okay, we need all these things, and also we need to be alert and not tired so we can see correctly. So that we have, as we can see, three factors that can be divided into three categories. We have the task itself, and we have the lighting condition, and we have the observer. Each one of them has certain characteristics that or properties that determine the performance of that visual task, whether it's a good visual task, if we're going to achieve the reading we want or not. So first, let's talk about in general, what are the related factors of the task. As we can see, we listed here the size and proximity of the task. For example, is the writing is it in good font size, exposure time for how long I am able to see that writing, for example. As we can see in here, this is an example of a sign. You see it only for a short period. For example, if you are reading in a book, you are going to like you have more time to read. Brightness, also brightness, this is related to the task. Now, you don't confuse the brightness with the brightness of the lighting. Brightness of the task is how the task itself, the colors of it, are they bright enough or not? Contrast, if you have, they are almost related to each other. So if there is contrast between what you want to see and the background of what you want to see, and familiarity, the content itself, are you familiar with it or not? Of course, if you are familiar with it, it will make the reading task easier or any visual task. Now, the lighting condition in here, we have three categories, factors in the lighting condition. We have something called illumination level, definitely the lighting level. For example, you have 100 lux, 300 lux in that area. Are they enough for reading? Brightness ratios, okay, the surrounding areas, are they bright or not? Okay, are you comfortable in the space? Because the brightness ratios are suitable. Glare issues, for example, is something in front of us, for example, like a lighting producing glare. Will it be in disable you from reading, or is there a reflection going on the paper you are reading from? Okay, these are so, like I told, the three factors related to lighting condition, which we are going to talk about more in depth later on. And these, as we can see in here, the factors that affect the observer, in general, they are determined by the observer age, by his health as well, by his condition. Did he get enough sleep or not? Okay, as we can see, conditionalized adaptation, all these related to the observer health, let's say. So as we can see in here, we have an example of a street sign, a highway sign. As we can see in here, the sign we only let's examine each factor of these. So first, let's talk about the task itself. So our task is to read the highway sign while we are driving. So first, let's talk about the size and proximity. As we can see, they made the letters in a larger size than usual, so we can see it right away and read it right away. Exposure time. Exposure time is very short in our task in here. So because of the exposure time is very short, which is going to lower our performance of reading that sign, so we have to take it into consideration and compensate for that by adding the size, adding the brightness and contrast and all the other parts so we can make it still easy to perform. The brightness, definitely there should be brightness enough for us to read. As we know, during the day this is clear for the reader, and during the night, as you know, the lights will reflect off the white part because it's going to be reflective material, and the green part is going to be matte material. So that way people will be able to read. Contrast, there should be a contrast definitely between the background and the letters that we have to read, and familiarity. Now, familiarity, whether the content is easy to read or not. Like, for example, they used like easy to get symbols. For example, we have the 90 is very clear, it's a number. East is very clear as well. Boston and an arrow, definitely everyone can read the arrow. So all of them should be like symbols that the driver is familiar with from before. Okay, lighting condition, as we know, during the day they have enough lighting conditions, brightness ratios and glare. As I told you, the materials are suitable not to produce any glare at night or during the day also. Okay, the observer, the driver definitely has to be in good conditions while he's driving. Okay, so I'm going to talk about each one of these in more depth now, the task itself and its properties or its characteristics. Okay, the size. Now, when we measure the size of anything in the task, we don't measure the, let's say, the height, okay, or the width of it. We measure the exposure angle. Now, exposure angle is defined by the distance between the observer eye and the location of that task, and defined by the height of the task. So as we can see, so instead of saying the height, we are taking into consideration how far am I from that task and taking into consideration the size of that task. So these combined will produce in here the exposure angle. Now in this image, what we are showing in here is, for example, we have the same letter or the same arrow we are looking at, okay? The visual task is the same. But in here, it's brought closer to the eye, and here it's brought further from the eye. Now, common sense would say if you take it further, you will see it as smaller. Okay, if you bring it closer, you will see it as bigger. So if it's bigger, then you will see it as better, okay? So in here, how we define this by the exposure angle. This is the exposure angle in here. See, it's smaller, defined by the edges of the task and by the source of the observer eye. So this is the angle here and this is the angle here. Now in this condition, as we can see, the angle is larger. So since the angle is larger, so definitely this one is performed. This task is seen better. Okay. Now let's imagine another condition. For example, let's say that both of them are at this location, but I still have the exposure angle of this one. Now, if the exposure angle is going to remain the same, so it's going to reach this edge. Imagine that this arrow is this size, so we have two tasks at the same distance from the eye, but one of them is larger. Definitely also this one will be bigger or perform better. Okay, now this is about size and proximity. Now let's talk about familiarity. Familiarity is the content that you are reading is something that you know from before. So for example, we have in here letters, you know the letter A. If you started, for example, reading a different language, let's say a French or let's say Spanish or any, let's say Hindi language, okay? So when you read it, you're not going to be familiar with it. So no matter what the size is, the size of the task is, you're still going to be hardly reading it, okay? Now let's talk about the exposure time. Exposure time, as we spoke before about it, as we can see here, the cars are driving at a high speed, so their exposure time is going to be only like a couple of seconds or sometimes part of a second. Okay, which makes it's going to affect the performance of that visual task. Now let's talk about the brightness. Task performance increase with increase of definitely. If we have more brightness, we're going to see better. Okay, for example, in here, This is an increase in size of the letter. If we increase the size, we have 25% an increase in performance. If we increase the illumination on a letter, for example, from 100 lux up to 10,000 lux, also we are increasing the task. Now, the increase we are getting here by increasing the size is almost the same increase in performance as the increase in illumination we have in here. Okay, we don't have to measure to actually memorize this, but we have to just understand that both of them are increasing the task performance uh, equally if we increase. Okay, now brightness level. Now what we're reading in here, brightness levels are will increase the performance of the task, but the thing is, it's not going to be linearly uh, uh, associated. For example, as we can see in here, this is a performance. Okay, and we have in here illumination. Now let's ignore the curve at the top. Let's talk about this curve. We have one task of a small or medium contrast, let's say. Like for example, this one, okay? This A with the background of gray. Now if I increase the illumination, the task will be seen better. For example, if I had 0 lux, I won't see the task. If I increase it from 0, this is in foot candle. If I increase it up to 10 foot candle, see the performance will increase by 20%. 10 foot candle, which corresponds to 100 lux. If I increase it up to 50 lux, which is here, 50, sorry, foot candle, which is 500 lux here, is going to still be linearly increasing. Now, after the 50 foot candle and 500 lux, as we can see, the increase in performance is going to be less, okay? So we're not going to be increased dramatically now. It's going to be increased insignificantly now until it reaches here almost up that line. As we can see, like the increase is going to be only 1% increase in performance, even if you increase from 4,000 lux up to 10,000 lux, that increase is going to correspond to up to, for example, 1% of performance. So as we can see, this is corresponding to the fact that we as humans, we see clearly at 500 lux. Anything above that will be like we'll see it better, but it's going to be seen insignificantly by our eyes because our pupils have very bright levels, let's say above 500 lux or let's say 10,000 lux or 1,000 lux, will start to adapt to a lower ratios of brightness, and then we'll see the task almost the same at these levels. Well, we don't have to actually know why we are getting this exactly, okay? You don't have to memorize it, just need to understand it, to understand that illumination level is required at a certain level. Then after that, any addition of lighting is not going to add much of the performance. Now in here, as we can see, if the letter size, as we can see in here, this was, let's say a small one. If I increase the letter size to a larger one, see how the performance in general increased almost like 60%. So as we can see, the illumination increase sometimes is not that effect or significant on the task, on seeing the task as much as increasing the task size, for example, or task brightness, or task, sorry, not brightness, a task contrast, okay? So I hope this is understood so far. Now, as we noticed from here, so illumination levels are not that important in our in performance. What is important is the size, what is important is the contrast. So in this example, as we can see, this is a museum of artifacts, okay? Now these artifacts, for example, you want to use a very low levels on them, so they use a very low lighting. But to make sure that this lighting is seen, that this artifact is seen from its surrounding, they have to make a contrast. So to make other contrast, they didn't light the corridors around it. So only put a low level lighting of 40 lux on this artifact, and they made the corridors of 0 lux level, or let's say 1 lux level, okay? So this created a contrast, and at the same time, we are still able to see them because we have high contrast. Now, the reason for this one here in this condition is because they don't want to damage these artifacts by exposing them to high illumination levels. Now, let's talk more about the contrast. As we can see in here, high contrast. In here, this is low contrast. What we are seeing in here in these examples that illumination of one foot candle is sufficient to read this. And in here, but we need a minimum of 100-foot candles to read this. 1 foot candle is equivalent, as we said before, 10 lux. So we need 10 lux to read this. And here we need 1,000 lux to read this because it's very low contrast. Now let's talk about the second characteristic, okay, which is the illumination level. So first we talked about the task. So now we're going to start talking about the lighting conditions. We're going to talk about illumination level. Then we're going to talk about brightness ratios and glare. So these are related to the lighting conditions, the light I'm putting on the visual task I'm having. This where we're talking about the task itself. So let's talk now about the elimination level. So in general, as a rule of thumb, if you have any task, like we've seen before, that we don't have to use high levels of lighting. So if you want to increase the lighting of a task, so it is suitable to actually use ambient light that doesn't exceed 300 lux, let's say a maximum of 300 lux, just to see the surrounding area, like doesn't create high ratios of brightness. And then the visual task I have, if it needs more lighting for it, then I can add task lighting for it, which will increase lighting on it. In this way, I'm not going to waste my money on the energy for adding brightness that is not needed for the whole area. And this way, I'm adding only on this spot. Okay, now what is the needed lux exactly? So there are recommendations for each task, visual task. For example, in here we have this visual task. They are describing it, and we have in here examples of that visual task. For example, a design studio, critical work areas. Design studio is categorized as a performance of a visual task of low contrast and very small size over a prolonged period, okay? Because design studios, you need very detailed work. So you need detailed work, so you need to have high levels of lighting. So what is recommended for design studios is a minimum of 1,500 lux. Now, if you want to look at, for example, offices, we have a minimum of 750 lux. So these are recommended by lighting government or lighting not government lighting institute that is have studied all this and told us as designers what is their minimum requirement. Now, what we also need to know, these are recommendations for the task lighting. For example, here the reading, the task in here, I need this amount of lux. For example, if I look for something reading, so let's say this one or any of these, let's say this one. So we need to read 750 lux. If I need in here 750 lux, I need to also know from that a factor of that lighting, what is the needed ambient light of the area. So as a rule of thumb, they're telling you, you get the task lighting recommended. Now the general area surrounding it, for example, the lighting from the ceiling in here, should be 1/3 of that visual task lighting. Then the non-critical circulation lighting somehow not very adjacent to my visual text. For example, a corridor that is leading to this room or an area that is far from this area, from this desk in this room, it has to have a 1/3 lighting of the ambient lighting of the 1/3 of the task, meaning that non-critical room has to be 1/3 of this lighting. Then if it's 1/3 of this lighting, it's going to be 1/9 of the task lighting. Let's have an example. I have an example of an office with a task of medium contrast. So I'm asking you to recommend for me the suitable lighting levels for the task lighting, which is on here on the desk here, and I need to know the general lighting recommendations and corridor recommendations. So the first thing I told you to find is the recommendation for the task lighting. As we know, we have recommendations in the table in here. So to set the task lighting we have in here is the office with a medium contrast task. So it is here. See, office, visual task of a medium contrast or small size. So our recommendation is 750 lux. Okay, I put that part of the table here. So my task lighting is 750 lux. I put it in here as well. So my ambient lighting is going to be, like I told you before, it's going to be 1/3 of the task lighting. So in here, the 1/3 of the task lighting is, I'm going to define this one divided by 3. So 750 lux divided by 3 is going to give me an requirement of general lighting of 250 lux. Now, if we have a corridor, as we can see, this blue area or a corridor here, away from this area, now what is the required lighting for that area? It's going to be 1/3 of the general lighting here. So 1/3 of the 250 is going to be to divide 250 by 3. We are going to get an approximate of 83 lux. And here, this is all our results put in this image and written here. Now, illumination levels, what is the acceptable illumination general levels? For each country, they have different levels. This is according to their adaptations, to their exterior lightings, to their energy requirements. Okay, so this is set by the country itself sometimes. So for us in here, what we refer to, we refer to the standards for the United States in these ones. Okay. Now, there is something else related to illumination levels in, let's say, offices, okay? So, as we know, they all it's so we so far spoke about the quantity of lighting, the lighting level. Now, we have to take into consideration the quality lighting. Now, to achieve a quality lighting, you need to take into consideration the human factor in it. So when I say human factor, the human needs and human wants, okay, and human health, okay. All this we need to take it into consideration. So as we know, we want to increase the illumination level or use the correct illumination level to increase the performance of the task. Now, there's something related to increasing the performance of any task or any let's say work. So this is the Hawthorne effect. The Hawthorne effect is just saying that you can increase the productivity by increasing the flexibility and individual control in any work environment. So if we're going to apply this on the lighting environment, so we are going to allow the workers to have control and to be more flexible with the lighting of that environment and ask them every now and then what are their wants and needs to accommodate the lighting accordingly. So as we can see in this image, what is depicted that the boss is asking the employers, the workers, what are their needs. As we can see, we have a general lighting in here. This is at the minimum required lighting, and each one in one of them is holding his light with his hand, and he is controlling it by himself. And he's giving feedback to the boss so they can change, for example, the ambient light if they want, or they want to give them more control of their lighting. Okay. Now, the second thing I want to talk about is brightness ratios. Now, brightness ratios, as we spoke earlier in the first lecture of lighting, we said that the eye cannot adapt to the whole range of all brightness of light. Our eyes are adapted or are function as adapting to a portion of that light because the brightness, the general brightness, it's can like start from 0 up to millions of lux. That's why we can't accommodate our eyes only to a portion of that. So as we can see in this example, what we are seeing in here. Now let's explain more these two images, then we're talking about the brightness ratios. As we can see in here, for example, I'm standing outside under a very sunny noon sun. Okay, and what I'm seeing is here, I'm seeing everything in the exterior clearly, but I'm seeing the inside as very dark. This is because my eyes are adapted to the very high illumination levels outside. Now, the portion I'm adapted to doesn't include the levels of the inside. Therefore, anything below the portion I'm adapted to is going to see it as very dark. So this is why I'm seeing the lighting inside the space in here from outside is very dark. I'm just seeing the lighting clearly of the outside illuminated elements. The same thing applies to the indoor condition here, the indoor room. This is the same room depicted in here. So when I'm looking from the inside, my eye is adapted to the low illumination levels of the indoor lighting. So when I see the outside lighting, which is at noon, is very high, my eye doesn't cover that portion. It's not adapted to that portion at that specific time. So I'm only going to see the lighting in these walls, this floor, the ceiling, the lockers, but I'm not going to actually include the lighting levels of these ones because they are way above what I'm adapted, what my eye is adapted. Therefore, I'm going to see anything above what I'm adapted to as very bright, as we can see in here. So now the solution for these ratios in here. So we have to take into consideration that always keep the brightness ratios, anything adjacent within any view, that keep them within the same levels of brightness. That not to make them, for example, as we can have see in here, the brightness ratio in here is outdoor to indoor. For example, indoor is 1. The outdoor is, for example, maybe million, okay, or 10,000, which is too much. We can't accommodate that. So we need to keep the brightness ratios to a minimum, 1 to 10, 1 to 100 as the maximum. Okay. For example, in this condition, if I want to take a very good picture of this one to include both outside and inside, the illumination outside should be somehow relevant to the inside. For example, we can achieve this in early morning or late afternoon. Or in this condition, I have to largely increase the illumination inside to be somehow related to the illumination outside. Okay. So these are the recommended brightness ratios as we can see in here. Now, when we are talking about brightness ratios inside a space, we are talking about the brightness ratios, for example, in here between the task, between the surrounding, between the corridor. These are the things we are related to in here in the space design. So like we said before, the tasks or immediate surrounding. For example, we had a visual task and the general lighting. So like we said before, the task it should be 3 times the general lighting. Like we said before, for example, we had the task light recommendation. So we designed the ambient lighting or general lighting to be 1/3 of the task, which is depicted in the ratio in here. Now, if we want to look at, we also calculated in here the corridors. The corridors are not adjacent, they are remote areas. So in here it's telling you that the ratio is 10 to 1, which we calculated before as 9 to 1. So it's almost similar. Task to remote surroundings, they are the surroundings that are a bit far away. So book to a remote wall, which is far away from it, should be their brightest ratio should be 10 to 1. Now task to general surroundings, for example, task to a surrounding that is not that far from it. For example, here, okay. So 83 should be related to the corridors, and if you have an adjacent surrounding in here, then it's going to be. So in general, this is telling you that if you are looking at the task, it should be highly illuminated. Anything adjacent to the task, let's say the desktop itself, should be highly illuminated, but doesn't have to be as illuminated as the task. Then as much as you go further away from the task, you can go and transition to a lower brightness levels. This is related to the visual stress. Now, what we are talking about here is visual stress and the angle center of vision. For example, I'm looking at the window. Let's say the window has, or this is not a window. Okay, let's say it's a window or a painting. Okay, the window. It has a certain brightness level. Now, anything in my field of view in here should be of the same level of brightness. Okay. Now, if the wall in here is not well illuminated, the same as the window in here, I'm going to see a difference in brightness. I'm going to experience something called visual stress. Okay. Moreover, this lamp, I'm going to talk about if this lamp, this illumination is going to affect my sight or not. Now, definitely this one, if it's going to be here, this one is going to affect me more than if it's this one or that one. Now, this one is way away from my sight vision angle, so it's not going to affect me. Now, B is going to affect me. Now, if I'm having a different illumination between C and the window, I'm going to experience visual stress because my eyes are going to be now and then adapting to this one, then going to adapt to this one. So this is going to cause my eye some stress. Then if the B illumination is also different from C and different from the window, my eye will be now and then adapting to the three of them simultaneously whenever I look at them, so it's going to cause stress for my eye. So this is why what we are talking about in here, we have to take into consideration my field of view. Anything I have within my field of view has to be in almost similar brightness levels, okay? Now let's talk about how can I control the brightness ratio. So as I told you, I'm looking at the task in here. So this is very bright. Okay, so I want to keep the brightness ratios at a certain level. For example, the wall in here. I need to keep it bright enough. How can I keep it bright enough? I don't have to actually put a force a light on every corner. Sometimes I can just by painting it with the correct light or correct color or just giving it a correct reflecting finish. And that matter, I will allowing it to be bright enough in comparison to my task. Okay, so I'm going to then adjust the reflectance factor. Now, the most important reflectance factor is the source of light in the ceiling, so the reflectance factor has to be high. So I have to reflect around 80% of the light of the ceiling. Then it's recommended for the wall to be 60%, then the floor is the least importance, and reflecting the light is 40%. Now, as I told you, we can achieve this by changing the light. Now, if you remember in the first lecture we took of lighting, we said that reflectance factor ranges between 0 to 1, and it's never 0 and it's never 1. We have a reflectance factor of a blue object of 0.05, which is 5% of reflection, and we have the maximum the reflection of a white, for example, wall is about 85%. So as we can see in here, 85%, so if I paint the ceiling as white, will be even better than what is recommended. So I can have an off-white color in here to achieve the 80%. I can paint the walls as white, or I can have a flexibility to paint it up to a beige color, which accommodates for 60 reflectance. Now we need to be also careful by avoiding selective illumination. What do I mean by selective illumination? When I'm distributing the light, I have to illuminate all the surfaces in that area. For example, in here, I illuminated only the tables, and this wall is not illuminated, it's a bit dark, and this wall in here. So no, I have to be careful by adding light to all the areas and illuminate all the surfaces in the space. So we have two things, directing the light on the walls and assigning from the start correct reflectance factor for the surfaces. This is how I can adjust the brightness ratios in a space. Now, let's talk about the third factor of illumination levels, or let's not illuminate like lighting conditions we spoke about earlier. Lighting condition, the glare. Okay. Now the glare, we have two types of glare. We have something called direct glare and we have something called reflected glare. Now direct glare is what you see, like you have the source of light right in front of you. Reflected glare is the light is being reflected off a surface. As we can see in here, this is the light source and this is the surface I'm seeing the reflection on my task. So this is indirect glare, and this one, like seeing the illumination dial itself, is direct glare. So now we have direct glare. Let's first talk about direct glare. Okay. Now, as I told you, direct glare is related to the light in front of you. As we can see, we have something called the direct glare zone. Direct glare zone is if you are seeing the light directly, for example, you are looking directly in the front. So this is your direction of sight. If the light is located here or anywhere between 45 degrees away from your sight, we're looking here, but the light is here, it's gonna still cause you a glare, okay? So this is what we mean by the direct glare zone. The light is within the field of view of 45 degrees above and below on the sides. Now, as we can see, this direct glare zone is being divided into parts. So the direction and the direction is the major glare one. Now, if you go further away from the center, you will experience something called discomfort glare, as we can see in here. This is discomfort one. So it's above 20 degrees from the center of direction. And we have something called disability. Now, disability glare is the one that you see in the front and it obscures the whole visual task you have. For example, let's have a look at both of them, discomfort glare and disability glare. Discomfort glare is, for example, you are looking at something but it's causing you some type of tiredness or causing you like you're squinting your eyes or not comfortable with looking at that direction. Now, disability glare is, for example, in here, you don't see anything from your while you're driving. When you experience this type of glare, it's going to cause you um, like impairment, okay, or disablement in your task, as we can see. Now there is something we need to take into consideration, like when do we have this glare? Now we have the glare when your source is very bright in relation to its surrounding. In this condition, you will experience glare. Okay, for example, in here, now this is the same light from this car and this car, but the difference is in this car, this is very bright too in comparison to its surroundings. So we experience glare when we are looking at it. And here, it's not that bright when comparing to its surrounding. It's almost the same brightness level. That's why we don't actually perceive it as glare. So, as we can see in here, more brightness of light is more than glare, more severe. Okay, the more the brightness the light, the more glare we are experiencing. Okay. Now, another thing we should also consider, for example, in this condition here, if you have this lamp is causing glare in both conditions, but the thing is, it's going to be more severe in this condition because the surrounding is darker. You have more brightness ratios. And this one is going to cause less glare condition. Okay. Now let's talk about, this is also the same explanation of what I explained here, but it's going to talk about the field of view. So as I told you, when I'm looking at the direction here, this is called the field of view. All this is my field of view. Okay, this is the center of the field of view, the zero. This is still within the field of view of the 45 degrees. Okay, so as I told you before, the closer to the zero center of the vision, the worse it is. Like for example here, the closer to the zero, the worse. The more you go further, okay, it'll cause you some tiredness, discomfort, but still it could be less severe. Now, as we can see, the exposure angle is a matter, a function of both size and proximity. For example, in here, this source of light in here, and this source of light, and this window. Now, these three lights, they are causing glare to his eyes. Now, this one's very bright. So when he looks at it directly, this is the major glare source. Now, this one, if I'm going to talk about the glare caused by the C location, it's going to cause also glare, but it's going to be more of the this type, the lack of comfort type. Okay, now let's talk about the third one, the B one. It's going to be somehow on the edge. Maybe it's going to be somewhere comfortable there. Now, if the angle is going to be more than 45 degrees here, if you have a light in here, it's not going to be within your field of view, so you're not going to experience any type of glare. Now, how can we avoid this condition? How can we avoid this issue, the glare, especially from ceiling-mounted fixtures? We can just cover the light source and diffuse the light. For example, here we have these three different covers of light. As we know, this one we find in our classrooms and the university. If you go to any classroom, just look directly at this light from the bottom and upwards. You'll see that the light is hurting your eyes, this white light. Okay, it's going to cause you glare. But if you look at it from an angle, you won't see the light source directly. So it's going to actually, you're going to see the reflection of light within these aluminum stripes. So it's not going to cause you any type of glare. Now these ones you can, the same thing, they are diffusing the light so they are reducing the glare issue. The same thing here with the diffuser which can be also designed uh, as well. Now this is explaining to you that when you cover the light, you should take into consideration that the light should be covered up to 45 degrees. For example, Now, as I can see in here, I'm standing, let's say here. We have standing here. So if I can see the light here, even though I'm covering it here with this one, with these sides, if I'm standing here, I'm going to see this one is going to cause me glare. If I'm standing here at this point, I'm not going to experience glare. Why? Because see for example here, if I'm standing at this point, I'm not going to see the glare source because I'm being obstructed by this side. So all of these luminaire covers, they should be taking into consideration where the viewer is standing and how he's going to look at it or not. Will he be sitting in which area? So you have to take all the geometry into consideration. Okay, there is something that sometimes you can't accommodate all the directions for everyone. So sometimes you just want to accommodate at least a percentage of people. Now, our optimal design, we need to cover the maximum 100% of people not seeing any type of glare. But sometimes we are going to achieve, for example, 90% of people not experiencing glares from this light source. So this is measured by something called visual comfort probability. VCP, it is the factor that predicts the percentage of people who will find a specific lighting system acceptable with regard to direct glare, which meaning that their location will they experience glare or not by calculating their percentage. Okay, so glare in lighting is the same thing as noise in acoustics. So glare is lighting that you don't want to see. For example, you are looking at a visual task, then you have a glare in between. Glare is unwanted light that you don't want to see that is obscuring you from seeing the visual task. The same thing in noise. Noise is when you want to hear something, then you get an unwanted sound, which we call noise, which is obscuring or covering the sound that you were trying to listen to. Now let's talk about indirect glare. Now, as we can see, indirect glare, like I told you, is light or light being reflected off the visual task. So what we need to always to think of here, our visual task location, our eye location, the observer eye location, and the light source location. All of these together will determine whether we're going to experience indirect glare or not. So in this example in here, what we see is this is our visual task. This is the center of the visual task. So what is happening is I'm looking at it from this angle. So if I'm looking at it in this angle, I need to consider if this will there be any reflections that entering my eye at this point. So as I can see here, when I uh, project this line from the center from the light, I see that when it reflects, now we are following the rule of angle of incidence should equal angle of reflection. Okay, now when this light is being reflected, it's going to enter my eye. In this condition, I'm going to experience uh, indirect glare. So how can I examine any situation? Imagine that I don't have these drawn in here. What I'm going to do is simply just I'm going to project the light from my eye on the visual task, then assume that it's being reflected off. To reflect it off, it's going to, for example, the line is stopping here. So from this point here, I'm going to draw a line that is perpendicular at right angle on my visual task, which is this line. Now I'm going to draw the reflecting line, which is this one, in here reflected from this one. Now when I see it reflected, yes, it's going to reach the light, meaning that this light is actually will reflect into my eye. Okay, how can I avoid this issue? Now, the first basic way to avoid it, for example, the visual task, not to make it reflective. Now, if it's a mirror surface, definitely you will be obscured by it. If the visual task is a matte finish, if a matte finish, you will not experience any visual task. It'll just illuminate it for you. This is easy when when you're not trying, for example, to perform a visual task. For example, here in our condition here, it's a bit difficult because he might be writing. He might be reading from a tablet, an iPad. So if I'm using these things, they're going to reflect, they're going to have the reflective surface. Now, for example, in here, the indirect glare and seen in here, now this finishing, I'm not going to read anything from these surfaces. So I just have to specify the material for the lacquers not to reflect the light into my eyes. The same thing for the floor in here. So as I can see, I can avoid by specifying flat or matte finishes using diffused light source. Now, the light source itself, not to make it a very like clear source of light, it has to be diffused. If it is diffused, now when I see the light reflected, I'm not going to see it that bright in my reflection surface. And the third one, which we as designers, we should always use, is we should avoid it by working with geometry. Now specifying the location of the luminaire and the visual task and the viewer from the start correctly. Now we have something called veiling reflections. Veiling reflection is the type of reflection that is indirect reflection happening on the visual task we have that is obscuring us, veiling us. Veiling is obscuring us from performing that task. For example, in here, it's hiding the letters. In here, it's reflecting and hiding the content, the screen of the computer. So we have these types of veiling reflections. We have specular mirror like this one, and we have semi-gloss surface, less severe. Now this one is a less severe one, like you can still somehow maybe see it, but it's very bright in this condition. So it's depending on the material of the surface. The more glossy it is, the worse it is. For example, sometimes we can experience it with pencil marks because pencil will also reflect the light. Now let's talk more about how can I actually project the reflected light and how can I work with geometry as I advised you to do in here. Now we have three conditions in here, or let's say two conditions. We have this person standing, we have this person sitting, and here, for example, he is looking at a flat surface. Here is looking at a flat surface, and here he is looking at a horizontal, not horizontal surface. The surface is a bit tilted towards him. Okay, now each condition of them will require a different location for light. So how can I know that each location of light according to the reflections? In my condition in here, for example, the first thing you need to do to specify the area that you should not put a light in is to actually first project two lines. The first line is going to be, both of the lines going to start from the source, from the eye of the observer, for example, here and here. Also, this is the source. And the lower line and upper line is going to include the task, visual task, the upper limit and lower limit. This is to define the whole area where you shouldn't put any light. Upper limit for light and lower limit. Now, for example, in here, I projected this line. This is the beginning of the visual task. This is the end of it. The same thing in here. This is the first and this is the end. Okay, and for example, here they did it for the middle. We can do the same thing here. It reaches because this is a perspective view. So let's assume that we have one here and one here. Now, what we are going to do is afterwards, we should see how this line is being reflected. This is to simulate if we have a light, where the light is going to be reflected into our eyes. So in here, what I'm going to do is, now I have a horizontal surface. So definitely the right angle one is the reflection is going to be the same thing but mirrored. Okay, so I'm going to put a right angle, a right line, and here perpendicular line on this point, perpendicular line on this point. Then I'm going to measure the angular reflection in here, the same thing here, and reflect it. The same thing here. Now I got this projected line, and this is the reflected projection. Same thing for these two. Now, what I found in here, when I projected these two lines, what I found in here, anything I put in this area will be reflected here into my eyes. So in this way, I determined the area where I shouldn't put my lighting, ceiling lighting. Now, the same thing is not going to apply. So I can put the lighting here, I can put it here, I can put it here, but I can't put it in this area. So we call this zone offending zone on ceiling. We call it offending zone. So I might in the exam just ask you, please, I'll just give you the person with the desk and just give you the ceiling empty. And I'll say I'll ask you using projections of light, of expected light on the visual task, please find me the offending zone on the ceiling of the light. Okay? The same thing we can do in here, as we can see, like I told you, we're going to have a reflection. Now, as we can see, the reflection should take into consideration this line. I'm going to draw first a line perpendicular on the surface. It's going to be a bit tilted as well. This is going to be the line. Okay, if I show it to you, for example, يعني approximately is going to be, or let's zoom in, maybe it's better when we do. So as I can see, this should be almost perpendicular. So this is my perpendicular line. So this angle should equal this angle, then I draw the reflected light in here. The same thing applies to this one. So if I copy paste it, it's actually going to be a parallel line, okay? So this angle equals this angle. I hope this is understood so far, because if you have it in the exam, you'll be able to draw it and find me the offending zone. So this one is a bit different from that one because this person is standing. But the difference is because he's standing and stepping further away, so it's almost the same. If you like reach this line in here, it's going to be almost the same thing. Okay. So we know how to design for avoiding veiling reflections. So we also have in here this example. This is if you have a very tilted, almost vertical screen. This is the same concept. So what they did is they drew the lines, the upper limit, the lower limit from the eye on the visual task. Then they drew a line perpendicular on the screen at this point and perpendicular at this point, and they drew the reflected projected lines in here. In this area we found that all this area, this part of the ceiling and almost all the part of this behind wall should not have any source of light, meaning for example if we have this person, we shouldn't put any window in this area or any light in this area. This is applicable also to a TV screen, okay, in the living room. As can see in this example here, this is telling us that a side lighting, see they examined that if this is going to reflect on the surface of the visual task, is not going to enter the eye. Okay, so it's not going to cause any type of glare. So this is, side lighting is actually very good. Okay, so in general, if you want to design to avoid glare, there are a couple of things you need to take into consideration. Not only glare, like to design for quality lighting, you need to design for glare and veiling reflections and brightness ratios. So to design for glare, the first thing you need to do, make sure there is no any source of lighting within the 45 angles of field of view. The second thing you need to take into consideration, veiling reflections, any reflections happening of the surface you are working on and in relationship to the window, to the ceiling lighting. Then you're going to examine the brightness ratios. Brightness ratios is related, as we spoke earlier, to the lighting of the surfaces surrounding you. For example, the lighting reflectance factor for the floor, for the ceiling, for the window, for the walls. Okay, now as we said earlier, the highest reflectance factor has to be for the ceiling, then walls, then floor. Now I'm going to talk about something that is some lighting designers actually use, which is called the equivalent spherical illumination. Now, as we know, when we measure lighting on any task, we measure it using the lux. We say, okay, let's say from this light, 500 lux is falling on this book. So I'm getting this amount of illumination. I should be able, let's say, to read it. Now, this equivalent spherical illumination is taking into consideration the illumination falling on that task and taking into consideration not only the illumination, not only the quantity, it's also taking into consideration whether you have any veiling reflections, any low quality, like obscuring your, like reducing the quality of the visual task. So as we can see here, above a certain minimum, a quality of light is more important than quantity. So we need to find a measurement, a way to measure both of them together. So it enables us to compare between different light sources or light locations, for example, as you can see in this example. So the equivalent spherical illumination is a measurement of both the lux illumination combined with the lighting geometry, which is taking into consideration any, like, for example, any issues like reflections and glare. So it's assuming first thing that, for example, it's called equivalent spherical illumination because it's assuming that the light source coming on that point here is coming from a hemisphere, okay, a half of a sphere. Now the light is coming evenly from all the areas. So any area that has any reflections is going to reduce the quality. So they're going to emit that light from that sphere. So it's going to reduce the number, or let's say the lux of that sphere. For example, as we can see in here, now we're not going to learn how to measure to find the equivalent spherical illumination, but when you find, you need to know that, like, if you're illuminating an object with 500 lux, it doesn't mean that you are actually achieving a high quality. You need to take into consideration its issues, viewing reflection issues. Okay, for example, here is telling you that you can actually get a quality from the same quality of the actual lighting system that is supplying 2500 lux, that is going to give you the same quality of spherical illumination of a light source of 500 lux. Okay, now what does that mean? That means because its illumination level, maybe there are 2000 lux that are wasted by reflections or any glare issues. That's why they are of no use. The only being used illumination is only this portion, the 500. That's why these two types, if they are going to, if this was, for example, we have a light source giving me an exact clear, no reflection 500 lux, is going to achieve the same quality of this 2500 lux, but of a wasted 2000 lux of reflections. Okay, let's talk about this example. Now, for this example, we have in here, these are the measurements. We have three disk locations and orientations, A, B, and C. As we can see, the measurement in here, 120, 90, 100, is measuring how much light is actually reaching the disk. Okay, so as I can see here, from this measurement, the most lighting is going on the B disk. Makes sense, it's on the orientation of the light source, and this one, then that one. The least one is the C one, okay? Because it's not directly under the light sources. But the thing is, if we have a look at this one and this one, they are going to experience a very extreme viewing reflections because of light source is right above the visual task. So by that, they're going to degrade the quality. They're going to degrade what's actually seen. So their quality is going to be very degraded. So it's going to be, if we measure it in the ESI, which is taking into consideration the reduction of the glare quality plus the quantity of lighting, is going to give a value, highest value for this one. Why? Because all the light reaching this disk is being sufficient and of a quality lighting. No veiling reflections happening on the surface. So you have 90 lux reaching the surface. You also have the same quality, the same amount being as ESI foot candles. It's the same amount. No reflections have reduced its quality. Now, as we can see in here, okay, we have 120 lux happening on the surface, but what's happening is like we have too many reflections that degraded the quality of the surface visual task, which degraded its ESI, sorry, into 3 lux. So it's equivalent to a 30 lux of no reflections lighting. Now, as we can see, this one here is equivalent to a 17 lux of no reflection lighting. So this one is still better than that one, but the thing is, both of them are very bad in comparison to this one here that doesn't experience any reflections. Now, as we can see, the recommendations that we seen earlier of task lighting, they actually took into consideration that some of the lighting will experience some veiling reflections and some degradation by glare. Now, not a very large amount, but the thing is, they took it into consideration like a minimal amount, and they said that like if there is no glare or no reflection, then the recommendation can be increased by 25%. Meaning Like for example, in an office, they are recommending to have 100 lux. Okay, now this 100 lux will take some glare issues, a bit of glare issues. If there are no glare issues at all in that space, then the recommendation is going to be 25%. The recommendation is the minimum required is going to be 75 lux. Now, let's look at so we understood in general what are the issues we need to take into consideration in designing the interior spaces. Okay, the location of the windows, the location of the lighting, the location of the object, the furniture, and all, and the reflections of the surfaces. We learned now everything all about this. Now we need to take specific cases, or let's say activity needs. Now each need has a certain sometimes needs. Okay, so we need to take a couple of them and have a look. For example, reading and writing. Reading and writing require a very high task lighting that doesn't obscure what they're reading, that we should have a high avoidance of reading reflections. So for this to happen, we should take into consideration the location of the light. Now, as we can see in here, this is showing us how this source of light is going to cause some veiling reflection on this surface here. And these two sources of light on the sides, they are going to give the same amount of lighting without any reflections in here. Now we are assuming that these lights are located at the ceiling. So as we showed you before, no reflections is going to happen from the side lighting. What's going to happen from the front ones? As we can see in these ones, for example, this is the side, no reflection. But from the top one or the slightly front, we might experience it. Okay, so a general recommendation is side lighting is most suitable, and another thing we should take into consideration that even if the light is right above you or behind you, the thing is you're going to find your shadow on the visual task, which is going to obscure also your visual task. Okay, even you're going to see the shadow of your hands. Okay, now let's have a look at the drawing, drafting and painting. It's almost the same thing, but the thing is, it sometimes can be on the wall or it can be also on a desktop. So it's almost the same recommendations. So the thing is in here we require more high levels of lighting, and we need to be careful not to cast any shadows because we are looking at a drawing sometimes very small details. We need to be careful that all the light is illuminating my painting correctly with no shadow casting. So it has to be somehow from the side. Now, now let's talk about a third activity type, which is observing a sculpture. Now, when we are observing a sculpture, we are looking at a three-dimensional object. So we need to see the three-dimensional features of shade and shadow, and it's how casting shadow on itself. So when I need to do lighting, I need to actually see that. So what I need to do is, first thing, the shadows. So to experience shadows, I need to be careful not to cast the shadow from all the angles. If I casted shadow from the top, from the side, from the front, from back, I if I casted shadows from all the sides, what's going to happen is I'm going to obscure the features, okay, the shadow casting. So I need to be careful to direct an angle lighting that at the same time doesn't come from the viewer point. It has to be a sided angle somehow between the viewer and the side of the object to create something like this one. Now this is okay. Now I created a directional light showing some shadow casting. The thing is, which is better than that one, but the thing is I can't see now the features at the back, which I need to add now for it something called diffused light. So now what we need to add for observing a sculpture is two types of lighting. A strong directional light that should come above and slightly to one side. Then the second one has to be diffused light of appropriate low levels that is very lower than the directional light. This is to create something like this one. here. The same concept applies when you are, for example, modeling a 3D shot for exterior building, for example, let's say 3D Max, and you are locating the sun location. Usually when you are locating the sun location, don't locate the sun behind the camera where you are looking at the building. And you don't either put it, for example, from right the side, okay, direct angle from the camera. Neither put it from the back or the top, okay. You should put it somewhere between the right side of the shot and somewhere between the camera view. So it has to be almost like 60 or 30 angle from the camera view to give the same effect of shade and shadow of the sun on the building and show its 3D characteristic features. Now let's talk about in here seeing a texture. The same thing applies for seeing a texture. Whether you want to see the texture like this or you want to see the texture like this, you need to be careful with your locating your lightings. So I think this one will show more imperfections and impurities. So you need to locate the lighting maybe right in front of it to hide all these imperfections. Now, looking at the painting, the thing in looking at a painting is very similar to what we talked about before in finding the offending zone. So in here, for example, we have this painting. It can be covered with glass. So we need to be careful that the light doesn't reflect on the painting. And we need to take into consideration that the observer can stand at any point near the painting, but it's not going to be that near the painting. It's not going to be right next to it. So we are examining different heights, different locations for different people. Now the right way to do it to actually examine this lower part and upper part and reflect them. Now we're going to do something general from the center. So they examine the reflection of this one where it's going to reach. For example, they reflected her side to this area and they reflected it. For example, they put a line perpendicular and they did this deflection. It's going to reach here. The same thing for her eye and the same thing for his eye. Now what they found that is the offending zone is somehow here. Now imagine that the light source I'm talking about, I'm examining also the lower part. The light is going to reach here, it's going to reflect almost where? It's going to reflect also somewhere away. So that's why I'm looking at this point because it's the upper part which is more concerned with this lighting. Now, as a rule of thumb, they found that the lighting should be a 60 angle from the painting not to produce any type of reflections on it, okay, at the upper part. Now, let's talk about the windows. Now, the windows are very important, especially at night. Now, as we can see, the windows during the day, when you are looking at the space, you will see them as dark during the day. And during the night, you will see the light inside. So you need to take into consideration these two things and how you're going to illuminate the inside, what type of glazing you will use. This, as we can see, this is a reflective glazing, which is reflecting the surrounding, which is not going to create any discomfort. And here also, it's giving like dynamic feel to the building at night because it's showing the lighting inside, but it's reducing the privacy. Now, the thing we should look at is the black hole effect happening in this area. Now, at night, what's going to happen is you are illuminating all the spaces and the outside is very dark. Because the outside is very dark, you're going to see it as totally black. Now, seeing this at night is actually going to cause some discomfort for you because it's going to cause some high brightness ratios. Okay, now this is very dark according to its surrounding. So it's going to cause some discomfort. So for us, what we should be doing at night is either I add the light for the exterior or the other method that we are always using is just put some curtains on it and obscure that view. You should take this into consideration. For example, sometimes the spaces don't have any drapes or any curtains. They're not always residential or hospitality spaces. Sometimes they are a museum or a restaurant. But if you have a restaurant, you need to take into consideration by adding light to the outside because you don't want to have this effect, which is called black hole effect. And adding a drape to the window sometimes is not desired. So you need to examine according to your case. Now, this is the computer monitor revealing reflection that I spoke earlier about. Like as a rule of thumb, what we need to do is we should have a general ambient lighting in the space because we are experiencing high illumination levels coming from the screen. So you need to have your surroundings somehow well lit. And the other thing, you need to be careful not to have any viewing reflections coming from a window or any lighting coming from your back. So put all the lighting, if you have a computer, put all the lighting at the back of the computer, not at the back of the observer or on the sides of the computer. Now, let's have a look at the biological needs of related to lighting, to good lighting. So we have something called orientation, simulation, defense, and survival. These are related to more of the human factors. So the first one is the need for spatial orientation. Sometimes when we are designing with lighting, we need to light the areas to orient the people, to direct them how to move around in the space. For example, in here, I want the people to know that I have a couple of steps in here. If it's not well illuminated, they might fall off or مثلا يعني trip with these steps. The same thing in here also, I want to redirect them in a hotel lobby. Now I want to make it clear for them where to find the reception. So I made the ambient light in this area at a low light. Then I made the lighting for the reception more brighter to redirect them into that area. Another thing related to need for spatial orientation is during the day. For example, I need to see the light from the outside, from the sun. I need to see where I'm located, at what time am I during the day. When, for example, you are in an enclosed space with no window to the outside, you are staying in that space, let's say an office, from 8 a.m. and you get out at, let's say, 7 p.m., sometimes 6 p.m., you'll find that you entered the space when it was sunny. Then all of a sudden you went out and it's all dark. So somehow you'll feel that you are disconnected from the world. So we need to orient the people to the outside world and to somehow show them their position to the outside, the level they are at, for example, here, at what level they are, at what time they are. All this is needed for their biological needs. Also, and this is also the thing I spoke about now, this is the need for time orientation, that you need to know that what time you are throughout the day. We also know that during the day, okay, the lighting will differentiate between the 8 a.m., 10 a.m., up to 12 p.m., then up to 4 p.m. But the thing is, this transition of light from the sun is at minimum, and the thing is, we are adapted to this type of transition. So it's not going to cause any effects on the humans. Okay, now the need to understand structural form. This is how I explain the thing about the sculpture. The thing is, if you want to see a 3D object or you want to see a 3D building or anything 3D object or element, you need to take into consideration how the light is falling on it. You need to have an ambient general light and you need to have a directional light falling on it to show what features you want. Now imagine if you have the directional light coming from here instead of from here, you're going to emphasize more on this tree he is standing on instead of the animal himself. So you need to be careful how you are directing your lighting. The need to focus on activities. Now, for example, in a restaurant, you have an activity of eating here. So you don't want the whole space to be lit. And each table will be just focused on with its lighting. So you need to just highlight these areas with addition more little lighting, depending on the activity you're having. This is just an example. So areas of high importance, more illumination. Areas of low importance, lower illumination. Now we have something called also the need for personal space. The need for personal space is, imagine that you are in an office with an ambient, very strong lighting that you will feel somehow that the light is being directed at you in addition to directed at the task. So what we need to do is direct the light only on the task and not direct it on us. So the focus we feel is not on us, it's only on our activities or our spaces around us. So as we can see, this is also similar. It can also happen in a living room. We need to feel that somehow secure and we are not Like the light is not focused on us in our living room. For example, in here, we need to light, for example, side tables. We need to light this. We have in here a desktop. We are lighting the desktop. In this example here in an office, how the light is, we have a general low ambient light, but the most of the light is on this desktop as well using the task lighting. Okay. This would produce, research has found that would improve that about 75% of workers would like to control this task lighting. This is due to personal issues. Okay, now the need for cheerful spaces. The need for cheerful spaces is very related to expectation. For example, I'm expecting the outside to be well illuminated by the sun. If I went outside and I found that it's overcast, I will be gloomy. I feel it's gloomy because my expectation is this. So although that overcast sky is actually casting some light, but still this is what I'm expecting, so I'll feel a little depressed. The same thing in, for example, this room. As you can see, this wall. Okay, this area is being illuminated, and this area, this table, only this corner is being illuminated, but the table is not, and this wall is not. So in this area, as we can see, it's better because all the corners needed are illuminated. I'm not feeling that they are dark areas. I'm feeling that everything is seen and clear on all the correct areas are illuminated well. And this matter is going to cause some cheerful feel to the space. Now, sometimes as I told you, it's very related to expectations. My expectation, and now before I talk about the expectation here, now this one will have caused some effect called cave effect. So this is why this is our biological orientation or expectation that if you have this light only here and the others are not well lit, you're going to feel that you are somehow entering a cave. Now let's talk about this expectation. This, for example, a restaurant. As we can see, our expectation is of low light levels. So because if it's a low light level, I can enjoy this space with these low light levels because this is my expectation of the space. Now, the need for interesting visual input. The thing is, it's very related to views and distant views for the eye. For example, in here, I can achieve it with with two things. The first one is adding windows with an external distant views, as we can see in here these two. And the second one, even if you have an office with some privacy, have your partitions low so that when you want to look away and relax the muscles of your eye, you can do that and just look any corner in that space without intruding the privacy of your adjacent offices. And the last one is I'm going to talk about the biological needs is the need for order in the visual environment. For example, as we can see, this is a building with a centralized design, okay, and we have a dome with this design at the ceiling. Then all of a sudden, I put the lighting, this rectangular lighting, somewhere in here. Now, when I look at it, I'll fear, and the light is gonna come from this source, and it's not coming from the center. Now, when I enter that space, I'll feel that there is not something unbalanced in that space. So we need to take into consideration the geometry of the space with the lighting allocations. This is very similar if you have a space and the lighting is not located in the center of the room. So you need to take that into consideration. And the need for security, definitely. If you have dark areas, they will cause lower security. If you have higher brightness areas, you'll feel more secure. Imagine that this staircase is well lit, you'll feel that it's very secure. But because it's dark, you'll feel it's less secure. Now, we can achieve this sometimes at outdoor exterior areas. For example, the building in here, if a dark color, it will cause some lower reflectance, less secure feel. Now, if I color it with a very light color, as we can see in here, it's going to increase the reflectance factor, increase the brightness. Falling on it will make it more secure to anyone walking outside. Now, another thing we need to know is light is very important for the health of the humans. As we can see in here, the seasonal affective disorder. This is one thing we need to know about. For example, seasonal affective disorder is SAD effect. is something that people experience when they are not when the sun is not coming out for certain days. This is usually experienced in areas like England, for example. They most of the time they have overcast sky in winters. So when they get this, they get depressed, and because the winter days are also short, they get depressed. Now, to avoid this, or to actually to not avoid this, to find a solution for this, they can get something called light therapy. They are experienced to levels of light that are very similar to the sunlight. So in this way, they won't feel this psychological effect. Now, light effect we should be careful with is it can affect our circadian rhythms, which is somehow related to our sleeping pattern. Now, what is affecting us, our sleeping patterns more, is the blue light more than the light near the infrared light. That's why they create a light therapy that is more near the infrared spectrum. So when I say light therapy, it can be this type of device, or it can be by introducing into the interior spaces more windows to the outside so they can relate more to the lighting to the outside. And as much as possible, the lighting from the outside introduce as much as daylight as possible from the outside to the inside. Like opening a window with a view is not sufficient. Okay, it will make them feel they are related to the outdoor, but I need to also introduce levels of light to affect their biological needs. Okay. Now, how the light is actually affecting our bodies, how we're affecting our photobiological effects. Now, as we can see, the first we are going to talk about three of them: melatonin suppression and excessive ultraviolet radiation, excessive visible light. Now, melatonin suppression is the thing is when we have dark areas, as we can see, melatonin production is being produced in the dark. Okay, now what happens when we get high levels of melatonin in the dark? Our body is going to produce melatonin, which is going to cause our body to feel drowsy, then sleep. Now, if this is avoided at night, what's going to happen is I'm not going to get any melatonin. For example, if I have high levels of lighting at night, so I'm not going to get any melatonin. So low levels of melatonin, I'm going to be more alert. Now, the opposite is if I have high melatonin levels, so if the level is very low, uh, level of light is very low, okay, below the required lighting, people will feel drowsy sometimes in interior spacing during the day. So I need to illuminate the space with the required illumination level to make them alert as well. Now, bright light that stops the brain from making melatonin should be above 1500 lux. Okay. So this is just telling us that light is very important for us, but the ultraviolet radiation or light near the visible spectrum, especially near the blue and violet light, sometimes have some issues on the humans. For example, in here, ultraviolet radiation can cause burns, can cause and it can cause a couple of issues, although sometimes it's being used for certain treatments, but an exposure to that, as we can see, it's actually affecting our biology of our body. Excessive visible light also sometimes near the ultraviolet spectrum, it will cause some headaches, as we can see in here. High exposure to this type of lighting, the fluorescent lighting, will cause sometimes headaches to some people. That's why we need to be careful with the light choice and the amount of light we are receiving. Now, rules of lighting design. Now we finished this lecture, almost finished this lecture, but we're going to talk in summary about the general rules for lighting design. So first thing we said, if you have a space you need to design for, you need to first know the task you're having. According to the task, you need to know the required illumination. Then you know the required illumination, the task illumination, the ambient illumination, the corridor illumination required. After that, you need to look for not quantity, quality. So quality is to avoid having low brightness ratio, high brightness ratio. So you need to take into consideration the reflectance factor of the surfaces, okay, to reflect more light. And if you make them of a light color, you are increasing the brightness in the area with a low cost instead of adding lamps. And for example, in here, for example, in this condition, if this was beige, it would be better than adding a lamp, maybe in high level lamp in here. Okay, another thing is manipulating the geometry between the viewer and the light too. This is also how to avoid direct glare and veiling reflections. This is how we learned how to find the offending zone and how to, for example, locate the computer area. Now, create shadows and shades if you have any 3D objects in your space or 3D furniture, let's say, or any elements, architecture elements. You need to know how to use ambient and directional light and provide the appropriate brightness ratios on it. Also, we talked about this one, apply brightness ratios, avoid too dark areas. Now, if you want to highlight an area, make sure to apply the correct brightness ratio as we can see in here. It's 1 to 10, or like we've seen before, the Museum of Mummies in Egypt, for example, showing Egyptian artifacts, okay. Use light colors to increase illuminations. This one I told you about, like try as much as possible have bright ceiling, bright walls, okay. And use daylighting wherever possible and add views. This is definitely like try as much as possible to use the daylight lighting instead of using electric lighting. And as much as possible, allow people to relax their eyes by seeing views to the outside. Okay, design using an ambient light for the whole space and task. This is the first thing I talked about as well. Now, career possibilities. If you are interested in lighting design, you can refer to this website and you can find a couple of information more about lighting. You can get this is in the US. Some people might want to be lighting certified after working for a certain amount of time, or maybe studying lighting. Now, the thing is, as a conclusion, we should design for a quality lighting, not quantity lighting. As we can see, these two examples in here, we have two different structures. This structure for the play area in here, as we can see, they have a diffused light which doesn't cause any glare when they look upwards, and still at the same time is introducing high levels of illumination of sunlight, of daylight. But this one is introducing some illumination of daylight, but what is happening is that we have opening, which is going to cause some type of glare when we look at the ball flying here somewhere when they are playing tennis, for example. So what happened is they had this issue, so they had to cover it all with with from the outside, and therefore they couldn't make use of the actually outside illumination. So this is it for this lecture. If you have any questions, please prepare them for next class. So before the exam, and good luck.